Thank you for joining the November 14th, 2018 call. This is on containerization of adapters for VOLTHA. Some continued discussion we'll be posting to YouTube after the meeting. And Dinesh, I'll hand it over to you then.
Yeah, I wanted this meeting mainly because I wanted to figure out the design for how many containers we can have per device. The last time we had some discussion how to organize the containers. For example, when we provision a one OLT device, do we have to fork a separate container for that or something like that? Means there were two options. That one, we will have one container which is a base container, and when we pre-provision the new device, we will fork a container in activate code or something like that. Or in pre-provision time, when we pre-provision a new OLT device, we just go and fork the another container for that particular device. So I wasn't sure where we can do and how we can do it.
And what is the reason that you want to have one container per device? Is it performance, for performance purposes? Is there any other reason?
Well, I think this again was there are some options for performance, being able to load balance each of the devices into different containers, potentially on different servers. Also, different devices with different adapters, supporting multiple different adapter types so that you could isolate, vendor X's adapter from vendor Y's adapter, so they wouldn't affect each other if there was, some problems in one of the adapters.
Mm-hmm. But the adapters itself, like for vendor X adapter and vendor Y adapter, there will always be different adapters. That's because they are going to support different device types. So because of that, then there will have to be different containers for that. But for the same device type, do we want, for example, we get a pre-prov message coming in for device type A, suppose.
But
do we want? Mm-hmm. Go ahead.
Well, the concern is that, let's say you have 100 devices. Do you want 100 instances in one container?
It depends. It depends of if it's going to be a performance problem, for sure we don't want that. But do we want to have? There's different ways to look at it. For example, I'll give you an example of the way we're handling that in the core. In the core, we are going to have in the 6 to start. We're going to have 6 cores, six containers, and there are 2 of them will be kind of active, passive together. So in principle, you can think of it as if there are 3 cores. So they will be handling all the requests and handling all the devices. And if we need more, then we'll just spawn the same core, another version of that core. So in a way, if we see that we have a lot of device to managers, then we just spawn another container. Is it what you're thinking to do, or is it when the request comes in, that's at that moment you're going to spawn a new container per OLT, for example? Is that what I'm hearing?
I'm not sure there was a suggestion yet.
So that was my question actually. If you remember, I asked because when we are doing a pre-provision, at that time we are just giving the type. So that means that the adapter should already be up and running, right?
Sorry, I didn't get the last part.
I was saying that during the pre-provision step, we just give the type there. So that essentially means that the adapter should already be up and running. The container should already be running, right?
Yeah, that's correct.
Right.
You don't know which type of adapter until pre-provision. Unless we're going to have one container that supports every adapter type, then it doesn't make sense. You'd have to do it dynamically at the time of pre-provision to see if that particular adapter type has a container or not, and then create one.
Yeah, well, the way it works currently, like when an adapter is up and running, it registers with the core and it registers with the type that. So that's how the core knows that such an adapter exists. So if during pre-provision time, the core there's a request coming in for a device type, and there's no such adapters, then the core can do either one of either reject the request, or, well, the second option, I don't think it can do that. I don't think it's up to the core to go and spawn another container for that adapter. That doesn't make any sense. So we can either let the core reject their request or just save the data for later on.
So this essentially means that all the adapters that we are, all the devices that we are planning to support, all the adapters for those devices should already be up and running.
Well, suppose you are in an environment that a deployment environment, and you have let's say 10 different types of devices that you want to support, and you want to manage it via VOLTHA, then obviously you restart the instances for those devices or those adapters.
Okay. So this actually then essentially means that we need to have one container per vendor type, if that is if we are thinking in that way, because at least that much containers we would need, and if we have some performance issues, then we can spawn another container for the same vendor type.
Yeah, you will have a container for a vendor type, and then you can scale that. You can have you can have 10, 20 of it. The thing that there's some management that is required once you start to have those different containers. Like you have 10 containers, for example, managing 100 devices of the same type. Then you'll get into this thing that we did in the core, and you'll have to do pretty much the same thing, well, similar, or you can have a different heuristic if you want. What we have currently, we get a request coming in, and in the core, one of the core will decide whether it is the one that is going to handle that request or not. So they'll make a query to the KV store and try to lock on the key, and if whoever get that key first is the one handling that request. That's applicable only for...
I got a question on that, Ken. Are you saying that one core could support multiple instances of the same device type in different containers if you had some sort of affinity, if you use the affinity router type of concept between the core and the adapter? Is that what you're suggesting?
Yeah, kind of. In a sense, suppose you have a it's much easier with a picture. It's suppose you have an adapter where you have that's supporting a device type, a certain device type, right? And you have another instance of the same container supporting the same type of device type, and each one of them is holding a set of devices that you're managing. So what we need is, when a request coming in from northbound, that the proper adapter gets a request, correct?
Right.
So the way that we do it northbound, and the way with gRPC and the affinity router, we could use the same logic in the southbound, or there's also another way to look at it. The very first time that a request comes in, it will, for example, it will say like uh, adopt a certain device. When you get this first message coming in, it's a generic message because at that time we don't know which, no adapters is sending that message, that device, right? It's the first time that request is coming in. So with Kafka, because they're all listening on Kafka, this message of adopting a device will be sent on a generic topic. One of those devices, well, all of them will get the message. So one of them will need to act on that. In order for one of them to act on that, then they will have to do the same mechanism that we did in the core, where they're going to go to a database and try to grab a key, and whoever gets the key first is the one that is going to take ownership of that device. And the moment they have ownership of that device, then what they do, they create a specific topic with that device ID, and they are the only one listening to that on that topic. Meaning, from then on, any request coming from no found will land to that adapter only, because they are the one managing that device. Did you follow me?
Yes, I did.
Let's take a step back. So the initial question was, what Dinesh was asking was about the decision to have a container for one container per vendor type. So I think the answer would be yes, we would have at least one container for per vendor type. And when the requirement increases, we will spawn multiple containers. And as you said that if we have multiple containers, then we need to have a logic like core where the KV store is asked when the request is received, and when you get a hold of the device ID, then other containers will just relinquish the timeout or anything what they have, and the container which has got the ID will keep on serving that request.
Yeah, that's correct.
Okay? So Dinesh, did you get the answer to your query?
No, the thing is that when we pre-provision, we don't give the device type. So how will we know what device type it is?
No, I think we give that minus T is, if I'm not wrong, minus T is the switch.
Yeah, you need to give the device type.
So, so suppose we have to fork the container. What I'm trying to understand is, does the OpenOLT has to fork any new adapters, or it is going to be done as a part of the core?
Fork new adapters? What do you mean?
No, fork new container.
No, the forking of a new container, that it could be an automated step, but typically like done based on certain data of traffic patterns and everything, to figure out like whether we need more containers or not. So typically you will just go and use one of the, for example, whether we use Helm charts or something else in Kubernetes, we'll just go and spawn a separate one, and you can do it manually, or you can have an automated process that look at some of the metrics before they spawn one of them. But it's not something that is, we won't have a container that will spawn another container, to answer your question.
Yeah. So right now in 1.5 we have class OpenOLT adapter, and in that adapter we when we start, we create one instance of OpenOLT adapter class, and in that we have the devices dictionary, where every time we add a new device, it gets added into it when we activate it.
Yeah.
That's correct, Girish?
That's right.
So now in 2.0 case, how that will change? That's what I wanted to know. Means what OpenOLT adapter has to make the changes for this regarding to that.
I don't think anything changes there. There will be a shim layer. I have not looked very deep into this, but from my understanding, we will have to develop a shim layer on top of OpenOLT adapter that interfaces with Kafka. And PONSIM should already have those references because
that shim layer is already there.
Yes. In PONSIM, similar shim layer has to be developed for OpenOLT.
Shim layer for Kafka messaging?
Yes, that's what my assumption is. Ken can correct me if I'm wrong.
Yeah, I think Shad wanted to have a shim layer that does two things. Basically, that shim layer will be southbound of that shim layer would be the OpenOLT code. So that would be the code that will be used whether we're talking with VOLTHA 1.x or 2.0. So that part of the code will remain as is, but the shim layer will have heuristics in it to talk to either Kafka when it comes to VOLTHA 2.0 or like kind of don't do much when it's come to 1.x. So it's really to abstract the northbound communication with the adapter. For 2.0, it will have to implement Kafka. 1.x is pretty much everything is inside the same container. It doesn't have to do much.
Yeah. So this shim layer is already there. Like it's a replacement of adapter agent.
I'd like to suggest maybe the shim layer emulates the 1.x core, so that the adapter can be shared between 1.x and 2.x without any change.
Yeah, that's a whole point that I think Shad wanted to do.
No, but I think Shad decided not to go ahead with that idea of having common code and things like that.
Oh, the only reason he decided against it is lack of resources. He's working on another project right now.
Yeah.
But
so
I don't think we really should try to design something that can have common code, because there's going to be lifetime in both 1.x and 2.x with this code. It's going to be hard to maintain.
Yeah, and the data model I looked at, it gets very complicated because we have APIs which are changed, we have APIs which are modified. So those APIs, they had to be added into the data model for making common code. So I don't think that common code part is going to happen. So what Ken you have done is you have different code base for PONSIM in 1.x and 2.0, right? So we'll have to do same thing, I think. I already discussed this with Shad.
Yeah, you can do something similar, but on the other hand, since we are migrating and we're doing something in 2.0, it may worth taking the time and do it right, in the sense of like separate the common code, like, so that you can have other adapters that are dependent on OpenOLT that can reuse those common code. Otherwise, other people will have to rewrite again from scratch again, right? So I think it's worth it to take the time to write it something more generic now than later. Well, that's my opinion. So it's up to you guys to figure it out.
Yeah, but are you saying the same thing what Shad was saying, that have a data model on top of it, which will take the southbound request to the adapter and distribute based on type of the version we are using?
Yeah, I think that would be a good approach. But then you have to look at the time that you have and everything, and whether. But it's always better to do it right the first time than have to make adjustments later on.
But that needs to be done before we proceed with any changes for OpenOLT adapter containerization, right? That has to happen before. which is not there yet right now.
Yeah, that's correct. If you want to have a specific shim layer for that, then yeah, you have to build it. But you can use PONSIM as an example and to create that shim layer.
But PONSIM right now doesn't have that shim layer, right? Because you have two code bases for 1.x and 2.0.
Yeah, it's because for PONSIM it's already different, right? But the layer, the communication layer with Kafka, all those different way of handling, a generic way of handling requests coming northbound and sending things into the core. Those are common code that you could reuse in the OpenOLT adapter. So whether you put that in a shim layer or not, that's really up to you.
So where is this layer right now for PONSIM in 2.0?
You won't see something like called it in layer. What you're going to see, you'll see things like core proxy, Kafka proxy, adapter proxy, Kafka messaging proxy. So all those combined together you can think of it as a shim layer.
But my impression was core proxy is a common thing for all adapters, right?
Yeah, they are. So all the things that I've just told you, like the core proxy, adapter proxy, and all those things, they are common for everybody. But what you would need to do is looking at OpenOLT code and figure out like in 2.0 how you're going to organize it so that it works for 2.0. And if there's a way for you to organize it for it to work for 1.x, so that's great too.
Yeah, but the thing is that there are basic changes into the APIs and things like that to share as a common code.
When you say changes in the API, which API are you talking? The API with the core or API internal to the OpenOLT?
No, APIs coming from that interface.py.
Yeah, there's some changes there. But there's not like drastic changes. There are some changes, definitely.
So then the shim layer has to know which version it is running, right?
Yes, it's really depend how you want to approach, how you want to design it. If you want to have a solution that is only for 2.0, then just implement whatever is in 2.0 API. But if you want to have a solution that that does both, then you need to design it that way, right? So
Yeah,
it's really up to you, like how you want to, what you want to support and how you want to design it.
Yeah, so my thinking was we can start with putting OpenOLT code into 2.0 base and make it work in 2.0 and then think about this common shim layer after we do that.
Yeah, that's also a good approach. It's not a bad approach.
So that we will know what it is.
The hard part about that is that there's going to be a significant amount of code change going on in the 1.x baseline, and keeping that in sync in the 2.x baseline as you progress. Girish and I are both working heavily on stories in 1.x baseline in OpenOLT and Resource Manager and type profiles. I think it would behoove us to try to figure out how to abstract the interface earlier than wait till later. You're gonna be doing merges every day, every week.
Yeah, So that's why I thought instead of waiting for this common code and shim layer thing, it's better to start with porting in 2.0 and then do this later on. So at least we have something to show for 2.0 PON OpenOLT.
But you can still design it so that the majority of the work that is ongoing in 1.x that Greg is working on and other folks also working on, you can design it such a way that this common code is shared among both 1.x and 2.0.
Because the thing is that see in 2.0 we don't use adapter agent at all, and here in 1.x we use adapter agent for communicating with the core.
Yeah, but it's
the agent, the shim that we need to add to 2.x.
Exactly.
So from OpenOLT's perspective, it's still talking to an adapter agent. It just happens to be a shim that's translating that into Kafka.
Yeah, that's the whole point of making that shim layer. Yeah. There would be changes in some in the APIs and everything, but the bulk of the OpenOLT code has nothing to do with Kafka or anything above it. So you want to preserve that and make it common.
If we could implement a adapter agent in 2.x that OpenOLT talks to, that's part of the container, that seems to be well worth the effort up front, right? Rather than waiting to redesign the whole shim layer.
Yeah, I agree with that.
Okay, I'll look more into it. Because the thing is that these are two different repos, right?
Well, I think we're also having some discussions about trying to figure out how to have a common repo. There's, I had a discussion with Chad about there's more than an OpenOLT code. There's OMCI code, there's Tech Profile, Resource Manager, Broadcom ONU, lots of different code that needs to be shared between the two projects.
Yeah. So I think Shad had started doing things in that direction too, but then we decided that we'll continue with porting code in 2.0, copy the code of OpenOLT in 2.0 and make it work into that repo.
Dinesh, is there anything that is other than timeline, anything that is preventing you from going the shim layer way?
No, means there is nothing to prevent as such. It's just the time and effort we will need.
Mm-hmm.
And how to work with two repos. And I looked at it in that data model. It's basically having one interface coming from the core, right? So because the thing is that this common code will work in two different environments, in 1.x mode and 2.0 mode. So and how to test that, because it will have two cores, right? Sending southbound request.
Two cores, what do you mean?
Means to test it like to make this work as a common code, it has to work with 1.x as well as 2.0 core, VOLTHA core, right?
Yeah, you can make it that way. Ideally, but the whole point, I believe, it's not really about 1.x or 2.0. The whole point is there's ongoing work going on with OpenOLT, and so you want to preserve that work. So you want to make that work as separate as possible for which version of course we have. So basically, you need to have a layer on top of that that isolate that code. The bulk of the work of OpenOLT has nothing to do with communication with the core. So that work you want to keep working on it, like it may be in its own directory, its own repo, that everybody's contributing to that. And the northbound, this is where you make the changes to figure out whether you're talking to 1.x or 2.0 or any other versions.
Sure. Let me look into that more.
I would suggest there's no need to create a shim for 1.x because it is the 1.x core that is the adapter agent. We just need a shim for representing that in the 2.x. I'd also point out that I think there's advantages to other adapters, like the Adtran adapter or some of the other vendors' adapters that aren't using the OpenOLT. If we create a shim layer, it would help them in their porting effort to the 2.x core also. They're talking to an adapter agent the same as OpenOLT is talking to an adapter agent.
Yeah. So that's why in this shim layer, I was thinking we could have different classes of APIs which are same and APIs which are not same, and then call them according to the which core it is running, right?
Yeah, well, it's a design choice how you want to approach it, right?
Yeah, got it. But then how we can test it? We can test it first with 2.0 core only, and then keep it same for 1.x.
Yeah, for sure you will have to test. If you want to have a support for both 1.x and 2.0, then you will have to test it against both, right?
No, the thing is that to make it common code, 2.x OpenOLT code will run in containerized version, and the 1.x will not, right? So their KV stores and everything will be different. Plus, the imports of all the modules will be different.
Yeah, things would be different. That's why you need to have a shim layer, right?
But how this shim layer can make these imports workable in two different versions?
You may need to have a different some code that you're going to use. Yeah, go ahead. Go ahead.
Well, my thought was that in 1.x, there is no shim layer. It is the adapter agent that's in the core. What we need is something to be a proxy, a facade, so that it looks like a 1.x adapter agent for the 2.x container. So in 1.x, there is no shim. It's talking directly to the adapter agent that's in the core. In 2.x, there is a shim proxy class that provides the same APIs that the OpenOLT is calling, but translates them into appropriate Kafka APIs, where the process here would be to look at all the OpenOLT, looking for how it uses the adapter agent and providing those same methods in the shim for 2.x.
No, but the problem is some of them have changed. Some APIs are modified and some are removed. So I wasn't sure what to do with those to make it common.
There will be some changes that that will be there. For example, like logical device management is no longer in adapters; it's in inside the core. So there would be certain things, but the whole idea is that the bulk of the code that is proper to OpenOLT, you want to preserve that, and anything else, you create a layer so that it doesn't matter to where you're talking. For example, you were talking about the KV store. Like once you're inside in 1.x, you're inside the core. So when you're talking to the KV store, you're using the core data model to talk to it. So if you have that kind of code in the OpenOLT that's talking directly to the KV store via the core, then obviously in 2.x you won't be able to do that. But what you could do, you could create a small like shim layer that your code talk to, and that shim layer figure out whether you are inside the core or you're in a container environment. And if you're inside the core, you use the data model of the core. If you're in your own container, then you use a different KV client. But your main code is talking to that shim layer. You may not have only one shim layer. You may have multiple shim layers.
Yeah. So that means everywhere you need to know whether you are running in 1.x environment or 2.0 environment, and based on that, you take a decision.
Yeah, I won't say everywhere, but you want to limit it in certain places. You don't want to have it all over your code. If 1.x do this, if 2.0 do that. No, you don't want that.
Yeah, that would look very messy. That's the worry I had for doing this.
Mm-hmm.
Okay, let me look at it and write up something, and then I'll discuss again with you guys. Because when I first investigated this, it didn't look that easy to just solve by shim layer. Because for example, in common code, the APIs which are removed and we don't need for similarly like logical port and logical device, what do we do with that? Like there you need to know whether you are in 1.x mode, then use logical devices. If you are in 2.0, you don't use logical devices, right?
Yeah, but that's what I'm saying is there will be some part of that code, but you need to isolate that code. Isolate it as much from your core logic inside the OpenOLT.
Yeah. So for containerizing this, what we decided is that we will have we won't create different containers for different devices. It is based on the device types, right?
Yes.
I think we bifurcated into this common code discussion.
Okay. So, Dinesh, any other query you have?
No, I had some questions about logical port and logical devices. How do we handle them in 2.0? We just don't make those calls for core.
You just don't create them. If you take a look at the Ponsim code, and you will see that, and you see the difference between 1.x and 2.0. Like you just don't create them.
Yeah. we saw those. So
Correct.
and yeah,
Ken, can you explain that a little bit more? You know, the bottom-up discovery, because I'm working on creating logical ports for the multiple uni story for Deutsche Telecom, and the device is creating logical ports. The device is the one that knows how many ports to create. Can you explain who's creating logical ports?
In 2.0, and this is based on it was not based on the new work that you're doing for multiple unis. We may have to make adjustment there. But basically, like in 2.0, the device, the adapters, they will create the physical NNI, the physical UNIs, and they are going to send that request into the core that they have created those UNIs and NNI. Then it's the core, when it looks at it has received those ports, it has received those devices, it has seen a state change on those ports and those devices. That's when the core decide to create the logical device inside the core, and then it created the logical port, NNI port, and also it created a logical UNI ports inside the core. And that's based on the state changes, but the adapters are still responsible to create the physical UNI and NNI port and send that to the core.
Okay, that makes sense. Who allocates the port number for the logical port? So, right, the current implementation has some expected encoding of what the logical port number is that comes in the flows from the controller.
Basically, like at this time, what we have been using mostly in the code, like in 1.x, we have been using that ID has been was created by the adapters, that unique ID. In 2.0, we are assigning, at least in the case of Ponsim, and that's really not a generic case, we're using the VLAN ID that was assigned to that UNI. This is what we're using. What if there's a need for the adapter to create that ID? Then what we could do is there is a request that comes from the core into the adapter to get more information about that NNI or UNI port, depending on what adapter it is. By that request that comes in, then if there is the need for the adapter to specify that ID itself, in a way the adapter to create that ID, then the adapter can set it up and the core will just use it as is.
And does that exist today, or are you suggesting that's how we could do it?
I think I don't think it's. I think the mechanism is there today. It's just a small change in the core to accept the ID that's coming from the adapter. So if the adapter set it up, then the core will just use it as is.
Makes sense. I'll have to see if I can find how that works. Okay. That might address Dinesh's question about logical ports.
Mm-hmm.
Yeah, and then in 2.0 you have get OFP port info and get OFP device info, right?
Yeah, that's correct.
So that is not there in 1.x.
No, that's not there in 1.x, because in 1.x the adapters were creating the logical devices and the logical ports, and they were specifying those parameters specific for that device and that port. So in 2.0, the code will still don't have that information. So that's why it needs those APIs to come into the adapters to get those additional information.
But then in Ponsim, because it is Ponsim, you could hardcode that information, right? But for other devices, we have to query the device and get this information, right, over gRPC.
Yeah, that's correct. Yes.
Okay.
And good you mentioned that.
It seems like the layers could still do that. If the shim layer could implement the create logical device, but all it's really doing is caching the ID information that the adapter is allocating for it, so that when the V2 core asks for it, it can return that ID.
Yeah, that's one way to do that. And one thing that I think that's a good point that you also mentioned, Dinesh, in the sense of if you have to go and query the ONUs, meaning those will take time. Currently, the two methods of get OFE port information and the devices info, those are in a way synchronous call from the core into the adapters, in the sense of the core is waiting to get the correct response. And for, like you said, in Ponsim, it's all hard-coded, so the response is very quick. But if in the adapter we deem that those things needs to be queried and that will take time, then I will need to make those calls async calls instead of a synchronous call as they are today.
Yeah. So is that okay?
Yeah, that's not a problem to to change APIs. That's all right. But I would just need to know, like, from people that are doing real adapters, how long that operation would take. If it's something that just take whatever is in memory and give it back, that's okay. But if it's going to be something that will really need to be a long query to the device, get data back and then send it back, then I would need to make that async.
Yeah, I think it is getting information from the devices. I'll have to look into again and confirm it.
Okay, sure. Let me know. Then I'll change it, and I will need to put another APIs in place, I guess.
But to me, looks like for containerizing OpenOLT adapter, there is a lot of code massaging needs to be done to OpenOLT code base before doing that.
Yes, I would say, like, it's before when you start to write code, like maybe it's better to think of a overall design, how you're going to approach it.
Yeah.
Once you have a design in place, then it will be much easier to go ahead and make changes to the code.
Okay.
I think what would behoove us is to go through the current code and find that every place that the OpenOLT uses the adapter agent, and figure out the API, and figure out how we can map that into the 2.x architecture. I really don't think we should be massaging a significant amount of the OpenOLT code, because then you'll be doing the same thing to the ADTRAN adapter, and then the same thing to the Tibet adapter, and all the different adapters that are all using the same model. If we can provide an adapter agent proxy that implements the same APIs and caches logical port IDs so that they can be queried from the core, I think our objective here is to analyze what is the adapter agent's API that need to be implemented.
I had looked at it. There are 72 places where adapter agent is called from the OpenOLT device to inform core various things. So in that sense, that would change to core proxy dot class. So that will change if it is in 2.0, otherwise it stays same.
One way that you can also look into it, if you have a lot of places where you're making call to adapter agents, then you can still make your call to adapter agent in those places, except you will have your own adapter agent, and your adapter agent will make those translation into the core proxy. So you don't have
to.
Yeah,
that's what I'm suggesting, Ken.
Yeah,
that's
I know.
Exactly what I'm suggesting.
Yeah. That is why you don't have to make a lot of changes, but coming some changes you will need to do. For example, the creating logical devices and all those things. Those you have to give it some thought of how you're going to do that.
What about the imports? those paths are entirely different in two code bases, right?
Mm-hmm.
So how can we make that into shim layer?
That's why if you have for example, if you have I think what Shad has was the common code will be its known repo. So the common code, you're not going to change it. It's you will have your own set of reports and everything. And then what you are going to put in the VOLTHA Go repo is your shim layer.
Okay, let me check with Shad again, and because we had pretty much decided not to go on this route.
Yeah, but whatever route you choose, it's better not to have to go and write the OpenOLT code again, right? It's you want to preserve most of the what has been done and keep the work going there on the OpenOLT.
Yeah. Okay.
Just a time check. I think we've got about 5 minutes left here. Dinesh, are there any other discussion items or anyone else on the call? Any additional comments or questions?
I think Arun had sent a mail about some questions. I'm not sure those got answered or not.
Yeah, actually, I got an answer for one of them, but for the rest of them, maybe we can have a separate discussion, or we can uh, have an email thread going on for that, Ken, if it is okay. But you were saying that it's better to have a call for that.
Yeah, for some of them, it's easier to talk about it.
Yeah, actually, some of the queries were around that Proto C and Proto S parts that I asked them. Do we need to make separate for OpenOLT, or do we need to move? What is the data that we need to put into it?
Those are just helpful containers that Proto C is really it's a container that hold all the compiler for protobuf, and the Proto S is the compiled version of those protos. So it's a container that hold all those protos that have already been compiled. And then once you start to create your other containers, you will see when creating the other containers, we import from the ProtoS. So we copy all those protos that are already been compiled into our container. So they are more like utilities, if you think of it.
Okay, but we would require them for OpenOLT as well, right?
Yeah. Well, it's really how you want to do compilation. If you want to use those utilities containers to bring those compile protos into your own container, then you will need them. But if you want to go and create your own set of protos separately, then you don't need them. It's really how you want to proceed.
I see. So either we can reuse them, or with the OpenOLT, or we can create a new if that would be the design decision.
Yeah, but also in OpenOLT you have your own set of protos as well, right? An additional set of protos.
Yeah.
So you need to know like how you're going to incorporate that with all those other common protos.
Yes, essentially that would also be the query. I mean, because OpenOLT have its own set of protos, so what will happen to them? Because when we'll move them to the 2.x repo, so either we merge them with the existing ones, or we create a new one for them. I think that would be
you need it's a separate directory for OpenOLT, and anything that is very specific for OpenOLT, I'll keep it within OpenOLT and don't put it everywhere. But if it's something that is common, then yeah, move it out, move it outside for it to be reused by other components. But if it's only OpenOLT, leave it to OpenOLT.
But how will it work in common code case, the protos?
What do you mean in a common case?
Like if we create a common code for OpenOLT for both the cores, then the protos stays in common core, right? Or we do have to move them into 2.0 core OpenOLT adapter. Means what goes into then OpenOLT adapter code in 2.0 and what doesn't go?
Well, in 1.x, you already have when you're building the OpenOLT, you take protos from the common, the VOLTHA common, and protos from OpenOLT specific. We will have to do the same thing in 2.0. That doesn't change.
Okay.
All right, and the another one was to how we actually test out the communication between the Kafka bus and the other containers which are created along with the adapter containers, because when we create a new one, we may also need to make sure that all the communication is happening properly.
Well, pretty much at this time, you have a bunch of logs on the core and a bunch of logs on the adapters. You can enable the logs at different levels, and you will see the communication happening. And you have a tool. There's a common tool that I use often. It's called Kafka Cat.
Okay.
That you could use to poke to look into the Kafka bus. That will give you the number of topics, the messages that are being sent. For example, if you're sending something from the adapter and the core, you don't see anything from the core, you can go directly using that tool. You can go and go on that topic itself and figure out what are the messages being published on that topic. That can give you an idea whether the message you're sending from the adapter is actually reaching the Kafka bus or not.
Right. Yeah, actually, I think I would come up with a more qualified question instead of a generic one, which I just wrote down in that email. Let us continue with the containerization effort, and I think we'll reach a point where I will have some more qualified question if I have some issue regarding the communication.
Yeah, sure, no problem.
Okay. All right, I think we are already, our time is gone, so I don't have any other queries. If anyone has anything else.
All right, I'll go ahead and get this recording processed and posted as soon as I can. It should be pretty quick, I think, since there was no video this time. So I'll go ahead, if there's nothing else, and close the bridge. Last call for comments.
Thanks, Ken. Thanks, Craig. Thanks, everyone.
You're welcome.
Thanks, everyone.
Thanks, everyone.
Yeah.
Okay,
Thank you, everyone.
Bye.
Bye-bye.